Welcome to the Explainer. Okay, imagine you're an auditor and you are staring at a literal mountain of financial data for a huge company. It seems impossible, right? Well, today we're diving into audit sampling, the smart and sometimes risky shortcut that auditors use to draw these massive conclusions from just a tiny slice of information.
So let's just start with the core problem here, what we're calling the auditor's impossible task. And trust me, the scale of this problem is, well, it's truly mind-boggling.
I want you to really think about a big, global corporation for a second. We aren't talking about a few thousand transactions. We are talking about millions. Every single sale, every purchase, every single year. So the question is, how could anyone on Earth possibly check all of them?
The short answer? They can't. It's just not going to happen. The sheer volume of it all makes checking 100% of everything completely impossible. I mean, it would take way too long, and honestly, it would cost a fortune.
Okay, so if they can't check everything, how in the world do they form a reliable opinion on a company's financial health? Well, this brings us to the hero of our story today, audit sampling.
The whole solution is audit sampling. It's kind of like a chef tasting just a tiny spoonful of soup to judge the entire pot. You're using a small but very carefully chosen sample to make a smart, informed judgment about the whole big pile of data.
The main goal here is all about efficiency. Auditors use sampling to gather just enough evidence to spot what are called material misstatements. And all that really means is errors that are big enough to actually mislead someone who's reading the financial reports. And of course, they have to do it all in a reasonable amount of time to make the whole audit practical.
So, how do they actually pick the sample? This brings us to the auditor's toolkit. And let me tell you, it's a lot more sophisticated than just, grabbing a random handful of papers off a desk. So, sampling methods really fall into two big buckets. On one side, you have statistical sampling. This is the scientific approach, right? It uses math to get an objective, quantifiable result. And then on the other side, you have non-statistical sampling, which it's more of an art. It relies a lot more on the auditor's professional judgment and their experience.
Now, the purest, most scientific method is random selection. It's basically like putting every single invoice number into a giant hat and just drawing a few out. This is the gold standard because it guarantees that every single item has an equal chance of being picked, which is absolutely the best way to avoid any kind of bias.
A more practical method, something you see a lot, is called systematic selection. So here, an auditor sets an interval, let's say every 100th invoice. They pick a random starting point, and then they just pull every 100 document from that point on. It's actually a pretty clever way to get close to true randomness without all the hassle.
And then there's the method that sounds exactly like what it is, haphazard selection. This is where an auditor, they just go for what's convenient. Maybe they open a random file cabinet and grab a few invoices without any real system. But as you can probably guess, this comes with a pretty big catch.
And here's the catch. It's all about human bias. I mean, even with the best intentions, an auditor might unconsciously pick items that are just easier to check, or maybe the ones right on top of the pile. This introduces bias, and a biased sample is basically a useless sample. It doesn't reflect the reality of the whole group at all.
Now here's a really clever technique. It's called stratification. Instead of treating all the data like one giant blob, auditors split it into different layers, or strata, for example by dollar value. They'll take separate samples from the small, the medium, and the large transaction pools. This is a super smart way to make sure those huge multi-million-dollar invoices definitely get a closer look.
All right, now this is where it gets really critical. Because sampling is a shortcut, right? There's always a flip side. There's always this inherent risk that you might have missed something really important.
This is called sampling risk, and it's the kind of scary possibility that the small sample you picked was, misleading. Maybe you just happened to pick all the good invoices, right? The ones with no errors, and all the bad ones were left untested. Your sample just doesn't represent the reality of the entire data set.
And this risk, it cuts both ways. The sample could look totally fine, which might lead an auditor to approve financial statements that actually have major hidden errors. Or the sample could look awful just by pure chance, leading them to do a whole bunch of unnecessary work. Either way, they end up at the wrong conclusion.
So, given this risk, how do auditors make that leap? How do they take the results from one tiny sample and then confidently project them onto the entire financial picture of a company?
Well, they do it through something called projection. They basically analyze the errors they find in their little sample to mathematically estimate what's likely happening in the much larger untested population of data. Okay, let's walk through this example right here. An auditor tests a $270,000 sample of a company's total $800,000 in purchases. In that sample, they find $5,600 in errors. Now, they split this up. $1,500 is an anomalous error. Think of it as a weird, one-off fluke that probably won't happen again. But $4,100 is a projectable error, a consistent issue that's probably happening elsewhere too.
And now, for the projection. They calculate the error rate from their sample, so that's the projectable error divided by the sample's value. Then, they apply that exact same error rate to the total value of all the purchases.
And boom! Look at the result. That $4,100 error they found in that little sample, it projects to a potential error of over $12,000 across the entire population. Now that's the power of projection.
For the final piece of this puzzle, they take that big projected error and they add back that one-off anomalous error they set aside earlier. This gives them their best, most educated guess for the total potential misstatement.
Finally, they compare this number to a limit they set way beforehand, something called the acceptable error threshold. In this case, their limit was $16,000. Since their projected misstatement is below that limit, they can reasonably conclude that the purchases account is not materially misstated.
But what if the number was right on the edge? Like what if it was $15,999, just $1 under the limit? Is that still okay? This right here reveals the most important insight of all. Audit sampling isn't just about the math. It's about where the numbers stop and where an auditor's professional judgment has to begin.